Hello everyone. Let's start the session for today. So today's agenda is to discuss about the JavaScript compilation. So we will discuss about the JavaScript compilation, like what happens inside the JavaScript engine. So when we give some piece of code to the browser, so we'll see what are the phases that it has to go through to execute that on the JavaScript inside the JavaScript engine. So we know that execution happens inside the JavaScript engine with the help of the call stack, callback queue, microtask queue, and event loops. And we have the memory management also, like the heap memory, stack memory to make the JavaScript code execute on the JavaScript engine side. So that is for the execution phase, right? So let's see what happens before that execution phase. There is something called the compilation also. So JavaScript does this compilation to improve the performance at the time of execution. So to make it more faster at the time of execution, it has to go through something called the compilation. So it will apply some kind of optimizations and it will compile and convert that to the bytecode, and then it give it for the execution later. So let's see what are all the phases that it has to go through while it is compiling it on the JavaScript engine side. So that is the agenda. So and also if we have time at the end, we will discuss about the exception handling and the ES6 features also. So let's move on to the first one, that is called the JavaScript. Let's see JavaScript engine side. So let's see what happens inside the JavaScript engine. So what are all the phases before we move on to the JavaScript engine architecture diagram. So first, the when we write some JavaScript code in any of the editor or any of the source code that we give it to the browser immediately starts parsing that. So the first phase of the compilation is the parsing. So once the parsing is done, it generates some kind of output, and that output goes to the compilation phase. So this is where we can see the compilation happens before inside the JavaScript engine. We'll see what is the just-in-time compilation also. So because the modern browsers, all these browsers supports the JavaScript just-in-time compilation. So in the just-in-time compilation, what is going to be happen? We'll discuss that in the in this phase that is called the compilation phase. Once the compilation is done, it will go to the execution phase. We already know what happens at the time of execution, right? So it will execute that with the help of the components that we have discussed already. So let's see the first phase and second phase. What we'll see more in detail about these two phases in JavaScript engine side. Okay, so let's see. This is about the architecture of JavaScript engine, right? We know there are several kinds of JavaScript engines available in the market. So the JavaScript engine, which is integrated with the Chrome browser, is V8, right? And the JavaScript engine, which is integrated with the Mozilla, is the Spider Monkey. So that is the first JavaScript engine which was implemented for the Mozilla browser. So once we write our JavaScript code in any of the editor, so as we discussed in the previous slide, it goes to the parsing phase first. So once the parsing is done, it generates the kind of output that is called the AST, that is called abstract syntax tree. So we'll discuss with the help of, let me write it down somewhere. So all these key points so that let me open the paint. And so the first phase is called the parsing, right? Once the parsing is done, it will go through the second phase called the compilation that we have seen, right? The second phase is called the compilation. So if you see this diagram, this entire cycle we will call it as the compilation phase. Okay, once the compilation is done, it will go to the execution phase. So we will see only these two phases for now, and we'll try to understand what happens inside the JavaScript engine side. So once the parsing is done, so inside the JavaScript engine, whenever it is parsing the code, it does the two things. One is the lexical analysis, okay, and the semantic analysis. Okay, so it does these two things whenever the source code comes to the parsing phase. What is the lexical analysis? What is the semantic analysis? We'll see about it now. So once this parsing got the source code, it does the lexical analysis first. So in whenever it does the lexical analysis, what happens here is like whenever you give source code, it divides that source code into the several tokens. So suppose if there is a source code, let me open uh, some editor like some notepad. Okay, if I write something constant number is equal to 100. Okay, if I write the source code like this, it will get converted to the number of tokens. Like how it identify the tokens, how this tokenization happens inside the JavaScript engine. So we know that the JavaScript lexical whenever the JavaScript code comes to the lexical analysis, it knows that what are the predefined keywords of the JavaScript, what are the identifiers of the JavaScript, what are the operators we have in the JavaScript, and the what it will identify all these terminologies, and it will divide that. Based upon these terminologies, it will divide the source code into the tokens. So if you see this piece of code, you can see, can identify that constant is a keyword, that means it is a token, and the number is an identifier, it will divide it as a token, and the operator is also a token, it will identify as a token, and then it will value is also a kind of token in the JavaScript. It will divide the source code into the tokens like this. Okay, this is called the lexical. This is what happens at the time of lexical analysis. Once it divides the token, it that immediately there is something called the semantic analysis starts. So whenever this semantic, what is the what actually does this semantic analysis means? We have something called the syntax parser. Okay, so syntax, what is the functionality of the syntax parser is to take the tokens which we have divided at the time of lexical analysis, and it will identify the meaning of those tokens also. So what is this meaning identification? Like whenever you write something in the JavaScript code, it tries to identify that if there are any syntactical errors on the tokens or not. Okay, it will check, it will try to cross check whether the code which is we have written in the JavaScript file is as per the standards of the JavaScript or not. It will identify the meaning of the tokens. Once it identifies the meaning of the tokens, if the source code is created as per the standards, then it will try to generate something called the AST. So that we have seen it here. The output of the parser is the AST. If we have not written the source code as per the standards of the JavaScript, then it will throw you some kind of error that is called the syntax error. So we have seen must have seen the syntax errors on the console so many times, right? So these syntax errors will be happen at the time of parsing phase, because this parser is the place where we get these kind of syntactical errors on the source code. So once the syntactical errors are identified, if there is no syntactical errors on your source code, then it will try to convert that tokens into the abstract syntax tree. So what is this abstract syntax tree now? So abstract syntax tree nothing but it's a tree kind of structure. It will get it will try to generate this abstract syntax tree uh, with the help of the tokens which we have generated at the time of lexical analysis. So there is a beautiful website available, astexplorer.net. So here you can see how this abstract syntax tree looks like. See, suppose if we write something, some piece of code, constant number is equal to 100. Okay, if I write some piece of code like this, this website is more powerful to create this abstract syntax tree on runtime. So you can see I have written only one line of code here, that is in the JavaScript. So it tries to generate this much of source code, this much of JSON object for this piece of code. Here you can see this is the tree kind of structure, where we can see the head of the tree, and also we can see the declaration section. Inside the declarations we can see what this is the variable declaration place, where we can see the name of the variable and the value of the variable. Also we can see what kind of a variable it is. It is a kind of constant variable, right? We can see what kind of a variable it is also. So this will create the JavaScript engine. The parser creates this abstract syntax tree. Once it is identified, the source code is as per the standards of the JavaScript. If suppose if I try to put some keyword which is not in the JavaScript side, it will throw you some kind of error called the syntax errors. We cannot generate the abstract syntax tree if there is some error, some compilation error or the syntax error on the source code. This is about the abstract syntax. It will generate the abstract syntax tree as the output of the parser. So once we got this abstract syntax tree, the immediately the compilation stage starts. So this is whole cycle. We will call it as a, it's not a cycle kind of thing, but it, this place we will call it as the compilation phase. Okay, what happens at the time of compilation? So before we talk about this compilation phase, we'll talk about two things here. One is the compiler. Let me write it down here so that we will refer it. So one is the interpreter. Okay, another is the compiler. So what are the jobs of these two? What interpreter do? What compiler do? So let's see if there is a, let's see about the interpreter first. So if there is a source code which you have written in any of the editor, if there is a source code, it will get parsed. It will try to identify the syntax that abstract syntax tree. Once the abstract syntax tree, once the interpreter got this abstract syntax tree, it tries to take the source code in the form of abstract syntax tree, and it tries to execute that source code line by line. It starts executing this source code line by line. If there are a number of lines in the source code, it tries to execute the first line of code, and then it goes to the second line of source code to execute. So when the second line of source code completes its execution, then it goes to the third line of source code. So it starts executing the source code line by line. So the interpreter doesn't know what happens at the time at the fifth line. So once the third line completes, then only it goes to the fourth line. Once the fourth line completes, then only it goes to the fifth line. It doesn't know what happens in the future lines. So that is the job of the interpreter. So what happens at the time of compiler? So what is the job of this compiler? Compiler is also same, like it takes the source code, whole source code, and it tries to compile it, and it will try to apply some kind of optimization techniques to while it is compiling the code, and also it generates some kind of some form of the source code that is called the optimized version of the source code. So compiler takes the whole source code, right? Once it takes the whole source code, it tries to optimize it, right? Optimization means we have some kind of optimization techniques so are there, right? Like the inline caching, copy elision, function inlining, memorization. These are all the optimization techniques, right? So these optimization techniques are different from one JavaScript engine to other JavaScript engines. So every JavaScript engine has their own set of algorithms to do this kind of optimizations in the JavaScript inside the JavaScript engine side. So once these optimizations are applied on the source code, it will try to generate this some form of the source code that is called the optimized version of the source code, or we'll call it as the optimized version of the machine code. Okay, so that is the job of the compiler. Compiler tries to execute the line by line, and interpreter tries to execute the source code line by line, and the compiler tries to execute the source code. So by compiling it, by applying some kind of optimization techniques, and then it tries to convert that to the other form of the source code that is called the optimized version of the machine code, and then it will again get converted to the bytecode, and then it gives it for the execution. So that's what happens at the time of compilation phase. Okay, that's the job of the compiler. So now if you see this diagram, we got this abstract syntax tree from the parser, right? Once the parsing is done, we got this abstract syntax tree. So immediately this abstract syntax tree, the source code, goes to the interpreter. Okay, so once this interpreter got the source code, it without any delay takes the source code, and it tries to start executing the source code, which we got it as a abstract syntax tree. It tries to take the first line of code and try to convert that to the bytecode and give it for the execution. Why we need to convert that to the bytecode? Because machines cannot understand the high level language, right? We are writing the JavaScript in the high level language. Machines cannot understand that high level language. We have to convert that to the some machine level language that is called the bytecode. So that's why interpret takes the source code. It will try to convert that to the bytecode and give it for the execution. Okay, while the interpreter is doing so it takes the help of the compiler also here. So interpreter talks to the compiler. It takes the help of the compiler, and the compiler takes the source code from the interpreter and starts the compilation phase. So starts the compiling the code. starts compiling the code. So what happens at the time of compilation, we have seen, right? It takes the source code and tries to optimize it, and it will generate the other form of the source code that is called the optimized version of machine code, right? It takes the source code from the interpreter and it tries to generate the other form of the source code that is called optimized version of the optimized version of your source code, that we got it as abstract syntax tree. So once we got this optimized version of the source code, it will try to convert whole code to the bytecode and give it for the execution. This compilation not only, it will not happen only in one phase. It will happen in multiple phases. Like it will try to generate the try to optimize the source code at once and give it for the execution. And then it tries to again optimize the source code by applying it. It will check whether we can apply more kind of optimizations on the source code or not. There is something called profiler between the compiler and the interpreter. So the job of the profiler is to check whether there is some places where it will identify what are the places that the compiler needs to needs to optimize the source code. Okay, so once the compiler identified the places, it gives that the profiling output to the compiler checks the places where it has to optimize the code, and it will apply the optimization techniques on those places. Then it will try to convert that to the optimized version of the machine code. Okay, so this compilation is happening on the runtime. So whenever we starts the executing the code, it tries to compile the source code, right? So this compilation is happening on the runtime. That's why we will call this, this terminal, this whole process as the just-in-time compilation, because this compilation is happening on the runtime. In the just-in-time compilation is nothing but the combination of the interpreter as well as the compiler. So it takes the source code and it will try to compile it on the runtime. So that's why we will call this process as the just-in-time compilation. So what there are some JavaScript engine which supports the AOT, ahead of time compilation also. What happens at the time of AOT is like it takes the whole source code which is going to be executed later. So it takes the source code and try to apply some kind of optimizations, and it will try to convert that to the optimized version of the source code. That's what happens at the time of AOT, ahead of time. You will try to optimize the source code which is going to be executed later, not now. Execute which is going to be executed later. That's what happens at the time of AOT. But just in time, it will try to optimize. It will try to compile it on the runtime. That is called the just-in-time compilation process. So this is all about the parsing phase and the compilation phase. Once this compilation is done, it goes to the execution phase, right? So we have seen this syntax errors on the console. If the JavaScript is identifying some syntax errors, this parser is taking the responsibility to identify that syntax errors. Once we got the AST, it tries to tries to compile it, and then it give it for the execution. Yeah, this is whole concept of compilation in the JavaScript engine side. So let's see with the this is whole process of compilation in the JavaScript engine. This is very generic for all the JavaScript engine, but let's see what happens at the time of with the help of architecture diagram of the V8 JavaScript engine. We know what is the V8. V8 is the JavaScript engine which was integrated with the Chrome browser. Let's see architecture of V8 JavaScript engine. So let me try to open images. Let me try to open the V8 architecture. Let me open this link. Okay, I have referred this blog to check the architecture of V8. Let me open this diagram. So if you see this architecture diagram of V8, this is similar to the architecture that we have discussed now. It will take the source code, and it will do the parsing. The parser is responsible to do the lexical analysis and the semantic analysis. Once it does those two things, it will generate the form of abstract syntax tree. Once we got this abstract syntax, it goes to the interpreter. So here we can see one name here, that is called ignition, right? What is this ignition? So the Google guys actually named the interpreter as a ignition. So they have given a name for the interpreter that is called ignition. Okay, so ignition takes the source code and tries to execute the source code by converting each line by line to the bytecode. Once we got this bytecode, and it will give it for the execution. So while it is doing so, interpreter takes the help of the compiler. Compiler talks to the interpreter and takes the source code, and then it will apply some kind of optimization here, and then how it will identify where exactly it has to optimize. The profiler as the is the place actually takes care about these optimization places. Right, once the source code is optimized, then it will try to generate some form of the source code that is called optimized machine code. Once we got this optimized machine code, it will try to convert that to the bytecode and give it for the execution phase. Okay, here you can see the name of the compiler also, that is called the turbofan. The compiler in JavaScript engine of V8 is the turbofan. So they have, so in several JavaScript engines we have several names also, like in the spider monkey, the compiler name in the spider monkey is the iron monkey. So they gave the different names for the compiler and the interpreter. So in the V8 they named it as ignition on the turbofan. Okay, so this is about the architecture of the JavaScript engine in Chrome browser, that's called V8. Yeah, that's all about for today. So this is about the JavaScript compilation. Thank you. Thanks for everyone.